That loud clunk you hear when a big motor starts, that is a contactor pulling in. It is the heavy switch sitting between a tiny control signal and a motor that could kill you. Press a button the size of your thumb. Somewhere in the panel, a slab of metal slams shut and feeds a motor hundreds of amps. So how does a small signal throw that much power? In this video, I will explain what a contactor actually is, how energizing its coil pulls the main poles closed, why it has to fight an arc the moment it switches, and how a contactor is really just a relay built for motor-sized loads. Let's start with the CLUNK. Quick note before we dig in. This is from PLC Simulator, where you can practice motor control and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to that contactor. So what is a contactor? A contactor is a heavy-duty, electrically operated switch. It is built for power loads, motors, heaters, lighting banks, home machines. Think of it as a switch you throw with electricity instead of your hand. It has three parts that matter. A coil, which is the control side. A set of main power poles, which carry the big load current. And a few small auxiliary contacts for signaling. The coil is the brain. The main poles are the muscle. And here is the whole point of the thing. A small, safe signal on the coil controls a huge, dangerous load on the poles. You never touch that load directly. That separation is exactly why contactors exist. Now, how it actually works? The coil is just a winding of wire around an iron core. Send current through it, and it becomes an electromagnet. That magnet pulls on a moving iron part called the armature. And the armature is mechanically linked to the main contacts. So when the coil energizes, the magnet yanks the armature in, and the main poles slam shut. That is your CLUNK. Full line voltage now reaches the motor. Cut the coil current, and the magnet lets go. A spring snaps the armature back, and the poles fly open. But here's the hard part. A running motor draws heavy current. And the instant those poles open, that current does not want to stop. It jumps the gap as an arc. So the main poles are built with arc chutes that stretch and cool that arc fast before it can weld the contacts together. That arc handling is the real engineering inside a contactor. This is where people get confused. Contactor versus relay. The simplest way to say it, a contactor is just a big relay built for motor loads. The physics is identical. A coil pulls an armature, and the armature moves the contacts. I have a full video on how a relay works, link below. The difference is scale and job. A control relay switches signal level or light loads, and it lives in your logic. A contactor switches motor-sized current, with much heavier contacts and serious arc quenching. So if someone asks the difference, you can answer in one line. Same idea, far bigger muscles, and built to survive the arc. Now where the contactor actually lives. On its own, a contactor is not a motor starter. It can switch the motor on and off, but it cannot protect it. Bolt an overload relay alongside it, and now you have a starter. It switches the motor, and trips if the motor draws too much current for too long. That pairing is the heart of the classic start, stop, seal-in circuit. An auxiliary contact on the contactor holds the coil energized after you release the start button. It is also the core of a star-delta starter, where several contactors switch the motor windings in sequence. Both of those have their own videos, linked below. So how does a PLC fit in? Simple. The PLC drives the contactor coil from one of its outputs. Turn the output on, the coil energizes, the contactor pulls in, the motor runs. But there's a catch. A big contactor coil can need more current than a PLC output can safely supply. So you almost always put a small interposing relay in between. The PLC output switches the little relay. The little relay switches the big contactor coil. That is the standard, safe way a PLC controls a motor. And it is exactly what you build in the simulator. So here's what to walk away with. A contactor is a heavy-duty switch for power loads. Energize the coil, the armature pulls in, the main poles slam shut, and the motor runs. It is built to survive the arc when it opens. It is just a big relay scaled up for motors. And pair it with an overload, and you have a motor starter, the thing a PLC actually drives. Get that, and every clunk in the panel makes sense. Now go make it concrete. If you want to practice motor control hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.